Hi, welcome to the Schiko Math Lab Mathematical Statistic Problem Solving session. So this is the problem we're going to solve today. So we have two A and B sets or the events. Now we have we call this the associated indicator random variable associated with these two events here. So what we want to prove is for the indicator of the A intersect B will be equal to the indicator A times the indicator B, or is the minimum value of the indicator A, indicator B. And the second part, after we solve the intersection, we will solve the unions here. Okay, so now let's go ahead, let's go ahead and start and try to solve these problems here. All right, so now let's try to solve in the first part. The indicator random variable of the A intersect B is equal to the IA times IB. And then is equal to the minimum value of the IA and the IBs here. All right, so before we solve it, let's first we'll define our indicator here. So what does that means? So the IA, so this is what we call is the indicator random variable. This random variable have two values, is 1 and 0. So if any number belong to A, then you will get 1. And if any number is not in this A, you will get 0. So my indicator only have two numbers here. All right, so now let's start to work on here. So we have the I, A intersect B. Okay, so that means this one will be follow my indicator random variable definitions here. So it will be equal to 1 if the x belong to A intersect B, or the x is not belong to A intersect B. Yeah. Okay, so now let's take a look what is the next ones here. Okay, so now let's take a look at the different situations here. Okay, so let's take a look at situation number 1. Okay, so if this is my A, this is my B, and here's the intersection. So now in here, like if my x here is inside here, all right? So for this situation here, I have x both belong to A and x belong to B, right? Because the x is in here, right? So this is x belong to A, x belong to B. Because x belong to A, so I know by the indicator functions, this indicator function is 1. And this one, what is that? That means indicate B equal to 1. It's correct. So now I have here, so this is IA times IB by what? So what will be here? Will be 1 here. Okay, so now also the minimum value of IA and IB, what is here? Is 1 and 1, so it's 1 here. So because this one is the x is in here, so this indicator A intersect B is 1 here. So the first situation I'll be able to prove the A intersect B equal to the IA times IB and equal to the minima IA IBs. Yeah. Okay. So now let's take a look at the situation number 2. Okay, so the situation number 2. Okay, so now let's see here. This is my A, and this is my B here. All right, so this is A, this is B. And now I'm looking for this area. So this is if my X is in here. Okay, so now let's take a look at what happens here. So for this one here, this situation, so this is x belong to A, right? Now this x is not part of the B. So what is this number? This number will give you the indicator A equal to what? Is equal to 1. And this ones here will give you the indicator B equal to what? Equal to 0. Okay, because the X is in here, is not in the intersection. So the indicator A intersect B will be equal to what? Will be equal to 0. Right? Okay, so now the IA times IB will be 1 times 0, so it's 0. And the minima IA, IB will be the minima of the 1 and the 0. So what is here is 0. So the situation number 2, I also proved that IA intersect B is equal to the IA times the IB, and also is equal to the minima of the IA, IB, right? All right, so the situation number 3, we can prove the situation number 3 is just like the situation number 2. So right now, I'm consider this part. So if this is my x here, so we can do the same thing. So this will be x is not equal to A, then this is x in the B. So that means IA here going to be 0, IB here equal to 1. So the same thing, A intersect B is 0 because x is not in there. Okay, so now we have to here IA times IB will be 0, and the minima IA, IB will be what is 0. So the situation number 2, we also be able to prove that IA intersect B equal to the IA times IB equal to the minima AB. All right, so the last situation, let me get rid of here. We already know it. Okay, so the last situation is situation number 4. So this is the, okay, so my x is outside here. Okay, so if this is the situation, so I know x is not in the A, so this is A, this is B, and x is not in the B here, right? So the IA equal to 0, IB equal to 0. Also, the indicator of A intersect B, what is here is 0 because x is not in there. So I know the IA times IB equal to 0. Then the minima IA, IB will be the minima of the 0. So it's 0. So I approve it. IA intersect B equal to the IA times the IB equal to the minima IA, IB. Okay, so here I should say minima, wrote too fast. So minima IA, IB. Okay, so now, I covered all the possible situations. So I know by exhaustion, okay? Of by exhaustions of all the possible situations. Okay, so by the exhaustion of all the possible situations. So that's why I proved that A intersect B is equal to the IA times the IB, and is equal to the minima IA, IB here. So this is the key things we use is by the exhaustions of all the possible situations. All right, so that's why I proved the first part. The indicator of A intersect B, is equal to the indicator of A times indicator of the B, and the indicator of the A, or is the minimum of the IA and IB. All right, so now let's go ahead and try to prove the second part of this problem here. Okay, so for this part, we can use the same strategy like we used for prove the previous one, is by using the exhaustions of all the possible situations here. All right, so right now we are looking for the I union B. All right, so just like so the I A union B. So this is the indicator function. So we do the same thing. It's 1 and 0 if X belong to A union B. If X is not belong to A union B. Okay, so now let's take a look at the situation number 1 here. Okay, situation number 1. So let's see here. This is A, this is B. Okay, X is not belong to, so that means my X is here. All right, so if this is the, so if X is here, so that means the X is not belong to A, X also not belong to B, right? So what is this one give you? So this one will give you IA equal to 0. This one give you IB equal to 0. So also, so we have A union B, because X is outside, what is here is 0, right? So the maximum of the IA, IB, what is that? So it's maximum of the 0, right? So what is that? It's 0. So I know I proved the first situation at IA union B is equal to the maximum IA, IB. Okay, so now let's take a look at the situation number 2 here. The situation number 2, so here, this is AB, and now that's the X is sitting here. All right, so let's X sitting here. So for this situation, I know X belong to A, but X is not belong to B. So what is this one? So this is IA equal to 1, IB equal to 0. And then the same thing so for the I union B. What is I union B? I union B, because X is belong to that, so it's 1. Okay, so the max of IA, IB will be equal to the max of 1 and 0. So what is that? It's 1. That's right. So I proved IAUB equal to the max IA, IB. Okay, so the same things here for the number 3, situation number 3 is very similar like a situation number 2 here. So this is AB, and now we're looking for this part. So if my X is sitting here, so we do the same things. X is not belong to A, X belong to B. So this one here is IA equal to 0, IB equal to 1. And because X belong to the union B, so I union B equal to 1. So the same situations here is max IA, IB is equal to what? It's max the 0, 1. So what is that? It's 1. So this situation I also proved I union B is equal to max IA and IB. Okay, so last situation number 4 here. So I have A, I have B. So situation number 4 is my X is sitting here. Okay, so when my X is sitting here, so that means the X belong to A and X belong to B, right? So this one, what is here? This will be IA equal to 1. Then this will be IB equal to 1. Okay. Then also I union B. What is this one? I union B is 1 because it's belong to A union B. Now the max IA, IB will just be what? It's the max, the 1, 1. So it's 1. So I proved this situation as well. I union B equal to the max IA IB. Okay, so I finally prove it by what? By the exhaustions. Okay, so by the exhaustions of the what? All the possible situation. Okay. Okay, so now we prove it. So this problem looks complicated, but after you going down and you find the proof really is pretty easy. All right. Okay, that's it. And looking forward. Hope you enjoy this problem and looking forward to talk to you in our next mathematical statistical problem. Have a good day. All right. Bye.